Yeah, this is a continuation. This is the continuation of what I was talking about, and we're gonna go through a leak code example. So the question is called number of islands. So you're given a m by n 2D binary grid, which represents ones and zeros, and the ones is land and the zeros are water. So gathering this information, we already know this is a 2D array. So in the beginning of the class, we already like learned about 2D arrays, and we knew how to traverse over, not traverse over them, or like yeah, kind of traverse over them and like search them and on like you know what I'm saying, and the conditions and the for loops you have to do for it. And perfect, we have that already in our head because we know how to do it. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. Remember this, not diagonally. Is it? Yeah, not diagonally, horizontally or vertically. That's all we have to worry about. You may assume all four edges of the keys are surrounded by water. So all four. So one, two, three, four. Let's say this. Like I don't know how to like. Let's like it's like this. One, two, three, four. All we gotta worry about, literally. So for the example here, I didn't understand this until I actually looked at the examples. So here we have this horizontally and vertically. Nothing else here. Like all this is just surrounded by um what's it called? By water. You feel what I'm saying? Like all this is the zeros is just water. And of course, we don't see land anywhere else except for when it's connected here. So it's all adjacent, right? So it returns one. You understand? So what I did and how I use BFS algorithm is first you had the let me comment this. So you had the result variable to keep track of islands. That's simply all that I did first. Let me fix this up so like it's visible. Yeah, so and then you guys already know this. I use two for loops to go over the first grid, second grid, 2D array, simple. And if grid of I of j equals 1, that's when it's already a land. That's when it's already a land. I just resolve. That's all. And then we call BFS. We call BFS. And here I'm using recursion to call BFS. Recursion formula. That's simply all. And I'm just increasing island. Island. Island count. Because simply that's the name of the game. That's the question. That we just want to know the number of islands. Simply that's all. And this is a very, very good question to understand BFS and recursion and everything. And I return the result at the end. That's nothing. And then I created a method to actually get this, kind of like we did in the assignment, um, but not really. I created a method to call BFS, and this is its base case, right? So its base case if it's not, I mean, if it's like outside the grid, if it's I is less than zero, if it's negative, whatever, return because it's void. I'm not returning anything. So that's just all. Grid of I equals zero. It's a water, and then it calls BFS, which means I go up, down, left, right. Game. That's simply all, fam. This is like I was so gassed when I get this question because it's simply so easy to understand, and recursion is such a simple formula and algorithm, and it's a medium. This is not easy. I mean, this is not medium. This is easy. So that's all you need to do. That's literally all you need to do. Recursive calls for BFS. That's literally all you need to do. And we run it. I did this question a long ass time ago. I actually don't know how I failed last time because I was like, but 84% passes, very good runtime. Let's analyze the complexity. Oh, I mean, I don't even know what that is. M times n. I don't think that's good. I suppose. But anyways, that's my BFS tree um video. So hope you guys understand. This is actually BFS. I didn't use a queue. I know mans that didn't use the queue. And I was like, oh, all you need to do use recursion. Call BFS, call BFS, call BFS, and simply you got your answer. So that's my Thank you.